This is Chapter 8, Lecture number 1. Things are going to start getting a little bit more difficult as we introduce our third type of bonding. We have an ionic bond between a metal and a nonmetal. We have a metallic bond, which is only within a metal. And now we have the third type, a covalent bond. So a quick review. The noble gases do not form compounds, which is group 18. This is because they have a stable electron configuration, because they have 8 valence electrons, or like helium, they have 2, a full shell. When bonds form, energy is released, and the compound becomes more stable. So metal atoms and nonmetal atoms become stable by transferring electrons, forming ionic compounds. Ionic bonds are the electrostatic attraction between ions. So in an ionic bond, an electron leaves one atom and goes to another. A covalent bond is different. It results when there is a sharing of electrons between two atoms. The electrons are shared between competing atoms to form a stable electron configuration. So here's fluorine that has 7 valence electrons. Here's another fluorine that has 7 valence electrons. Neither one is stable because they want to have 8, but neither can take the other one's electron because they both have the same electronegativity. So the best they can do is to share. So the 7 valence electrons from the one fluorine will, I'm going to draw these with X's just so we can see a little better. And the 7 valence electrons from the other fluorine will have one of the electrons from each bond or share. And that is what a covalent bond is the sharing of a pair of electrons. However, we have different types of covalent bonds. We can have a single covalent bond. So a hydrogen atom has a single valence electron. By sharing an electron with another hydrogen atom, it achieves the electron configuration of helium. In doing so, it forms the diatomic molecule hydrogen. So H with one dot for one valence, another H with one dot for one valence. They share the electrons between the two and form the diatomic 2 atoms hydrogen molecule. So now what we have to do is get used to building or drawing molecules. So complete the chart below, and for water, ammonia, and methane. Water's formula is H2O. So we have an oxygen from group 16 that has 6 valence electrons. It ends up sharing an electron between a hydrogen, which I'm going to draw with an X. And it ends up sharing an electron with another hydrogen. And there is our covalent bond. In a structural formula, we make things a little easier by making the shared bond a dash. But that dash represents 2 electrons. An electron from each atom. Ammonia. Ammonia is NH3. So ammonia has 5 valence electrons. There are 3 H's, so each H will share an an electron with each of the single nitrogen electrons, forming a nitrogen molecule. We can also show it with a dashed line, showing the shared pair, but then we have two unshared electrons at the top of the nitrogen. And then can we see where this thing's going to go? CH4. Carbon has 4 valence electrons, group 14, and there are 4 hydrogens, each with 1 valence electron. And we end up drawing this kind of a structure. Each dash represents the shared pair. So if we look on the next page, we see a water molecule, an ammonia molecule, and a methane molecule. And I think that's it for today. So have a great night, and we will see you tomorrow in class.